Hey everybody, this is Mr. Han, and here are our notes for the 5D process. So we're going to be writing equations from word problems and solving them. So here, let's take a look. The 5D process is known for the first D in the 5D process is when we draw or describe, and I'm going to get into detail in just a second, but just so you know what does 5D even mean. Draw and describe. Oh, great. Alexa, turn on the lights. The second D in the 5D process. Alexa, turn on the lights. Thank you. The second D in the 5D process is to define. Like I said, I'll get into that in just a second. Third D is do. Fourth D is decide. And the fifth D is to declare. So we're going to be doing this 5D process in order to solve word problems. Now, for the past couple of days, you have been working on taking shorter expressions like 12 more years than Dan and coming up with 12 more years with than Dan, and you define, no, we don't know Dan, so we're going to call it D plus 12. And that's what you guys have been practicing. Now, what we're going to do is we're going to take that concept and we're going to apply that in solving word problems. So we're going to go ahead and read this first word problem, and then hopefully I'll help you understand. Okay, we're going to use this concept, D plus 12 or Dan plus 12, X plus 12, whatever variable you name it. And we're going to solve for an unknown. So here, let's take a look. Example problem. And this whole first example is done for us, so we're not really going to do anything. We're just going to see what the process is. Alright, so example problem. The base of a rectangle, let me do that again. The base of a rectangle is 13 centimeters longer than the height. If the perimeter is 58 centimeters, find the base and the height of the rectangle. So here we're talking about a rectangle, and we know that the base of the rectangle is, now right here the base is being described, and the base is 13 centimeters longer than the height. So here we have two parts of the rectangle that are that have values, right? The base and the height have values in this rectangle. So we need to figure out what those values are to figure it. I mean, that's the question, right? Find the base and the height of the rectangle. So we have these two parts, and one of them is described. Let's read that first sentence again. The base of the rectangle is. Now, is going to be huge because we know it's describing the base. So the base is 12 centimeters longer than the height. Now, if you remember, 12 centimeters longer than the height would be h plus, not 12, 13, plus 13, right? So we could draw that out. H plus 13. And this is what we already worked on. The base of the rectangle is 13 centimeters longer than the height. Okay, so this is referring to the base. So we're describing the base, and the height is not described, and we just know that it's h. Okay? So here we go. Using that concept, right, to help us solve these equations. Now, that's the describe portion. So to describe this problem, we're talking about the shape. The shape is a rectangle, and we're looking at the perimeter. So here's another drawing of just a rectangle. We're going to be talking about the perimeter. If you don't remember what perimeter is, it's the distance of the outside of a shape. So we're going to go ahead and add all of these sides together. So to find the perimeter, right, we're going to have to add the height, and the base, and the base. And we'll get to that in the do section when we get there. So far we described and we drew it, right? You could either draw this, you can draw this. They're both drawing. And this just help you visualize, right? If you have a word problem, it might be longer than this, and it's just helpful to draw things that you understand to help you solve the problem. Now, the next part we need to do is define. Now, defining is important, and so this is the concept of a story, right? If you ever have a story, let's take the Little Red Riding Hood, right? In that story, you have characters, and so typically characters are described in the story, right? Little Red Riding Hood is a little girl that wears a red robe, um, and is going towards Grandma's house, and so she decides to go through the forest. And so Little Red Riding Hood, that's describing her. And the big bad wolf, right, ate the grandma. I mean, I'm kind of ruining the story, but sorry if you never heard it before. But the wolf, right, dresses up as grandma, is bad, and wants to eat Little Red Riding Hood. So those characters are described. Now here, in this story or in this problem, right, there was a character that was not described, and that was the height. So when there's a character that's not described, I want you to remember that, right? And your job is to introduce that character. So we went ahead and gave it a variable. And that's the idea that we learned last time. All right? Now in the define, all we're going to do is we're going to define the two portions, the height and the base. Here, the height is, we don't know it. And the base is going to be whatever the height is plus 13. So here, that's the defining portion. The do, what are we doing with the height and the base? Well, we're finding the perimeter of a rectangle. And remember, to find the perimeter, we need to add the height and the height and the base and the base. So here, you can see that the perimeter is 2 times the base plus 2 times the height. So that's saying 2, the base, whatever it is, times 2. Because if you add those two together, it's 2 times whatever number this is, right? And 2 times the height. So there is that. That's what we're doing with these characters or these parts of the problem that we're describing. The last step is to decide, well, is the perimeter, once we do, right, whatever we do, is it going to equal 58? And so now I don't want to confuse you here, but that's 4 of the 5D. But here, what we can do is we can guess. So if we don't know the height, we can guess. So there's these trials that you'll see. So here, you can use any trial value. You can plug in any number. 10. So let's say that the height is 10. I don't know if the height is 10. This is a guess. And so you could guess all day long. Okay, now I'm not going to ask you to guess all day long. I want you to get the answer, and I'm going to teach you how. But this is just to help you understand the idea. So if we said that the height was 10 of this triangle, and we want the perimeter to be 58, right? That means that the base has to be 10 plus 13. So 10 is the height plus 13. If we're guessing, right? If we're guessing that the height is 10, it's going to be 10 plus 13, which is 23. Okay. Then that helps us. If we know the base and the height, can we check, right? Is 2 times 23 plus 2 times 10, right? This is the base. This is the height. Does that equal 58? Well, 2 times 23 plus 2 times 10 is 46 plus 20. And that equals 66. So that's how this 66 is here. And the answer here is too high. 10 is too high of a guess. So here, we could sit here and guess all day. And so the idea is you can use any value, use the relationships stated in the problem to determine the value of the other quantities, such as the base and the perimeter. And then now, use the trial to create an equation by defining an adding. Okay, forget that, I'm just reading all this. So basically, it's saying this is too high. So, what can we do instead of guessing and guessing and guessing? Because I could sit here and guess, all right, fine, if 10 is too high, let's try 9, right? And I could sit here and guess all day, but I don't want to. So what can we do? This is the meat of the lesson here, all right? Let x represent the height. Whatever character or value is unknown, not described, give it a variable. And we've already talked about that in class. But here you can see that we gave the we could call it x. We're going to call this x. Let's go back here and just call it x so that we're consistent with the problem. So if the height is x, the base is x plus 13. So that's what we're saying here. If the height is x, then the base is x plus 13. And so, hopefully I'm not losing anyone here. We're going to go ahead and check. 2 times x is the base, we're going to put x, and 2 times the height, x plus 13, and technically those two got switched, but it's okay. What should this equal? The perimeter should equal 58. So right here we have the equation. Gosh. Here we have an equation. And once we have the equation, right, we can solve. So you can see that I can't talk right now. 2x plus, and then this got distributed, so it's 2x plus 26 equals 58. Combine like terms. Got 4x. Subtract 26 from both sides. Got 4x equals 32. Divide both sides by 4. X equals 8. So here is just solving for x. And so if x equals 8, that means that our height is 8 and our base is 8 plus 13. Okay, and that is 21. So now we can declare the base is 21 and the height is 8. Alright. So if you don't write an equation, you can solve the problem by making more trials until you find the answer. Now, hopefully you don't want to sit there and do trial after trial after trial. I mean, I hope you don't even want to do one trial. That seems like unnecessary. If you know that you can solve for it, why like guess and guess and guess and guess? So you take your pick. If you want to guess and guess and guess, go for it. Here, I'm going to do one example now. So let's go ahead and do the 5D process. Okay, this is actually a question from the textbook from chapter 2. So here, Susan is buying 3 different color tiles for her kitchen floor. She's buying 24 more red tiles than beige tiles. So right here, she's buying 25 more red tiles than beige tiles. So here, the red tiles are being described. And it's referring to the beige, so I want you to recognize that. And 3 times as many navy blue tiles, as beige tiles. If Susan buys 435 tiles altogether, how many tiles of each color does she buy? So here, what is this about? Let's go ahead and describe or draw. So we're going to go ahead and start here. Describe and draw. Well, this problem is about what? What is this about? It's about kitchen tiles and the colors. Right, what are the colors? Beige, red, and navy blue. Now, hopefully that's clear to you. Okay? And so, I'm going to go ahead and read it again, but I want you to take a look. Out of these 3, what color is not described? What color is not described? Right, or introduced. Let's go ahead and read that again. Susan is buying 3 different colors of tiles for her kitchen floor. Alright, we're going to talk about 3 different colors. She is buying 25 more red tiles than beige tiles. So here, she is buying 25 more red tiles than beige tiles. Who's being described there? Beige or red? Right? She's describing the red. It's going to be 25 more than whatever beige is. So beige is not introduced, but it's referred to. Next sentence. And 3 more as many navy blue tiles as beige tiles. So here what's being described? The navy blue. Navy blue is being described. There's going to be 3 times as many navy blue as there are beige tiles. Okay? So here, there's a character that's not described. It's beige and they're referring to it. So here we're going to go ahead and give it beige a variable. Okay? We'll call it x. So here, there's going to be 25 more red tiles than beige tiles. So red is going to be whatever beige is plus 25. Plus 25. And then navy blue is going to be 3 times as many navy blue as beige tiles. So 3 times x. So I'm going to duplicate this 3 times. 1, 2, 3. So I'll kind of bring these in together a little bit more. Alright. So beige can be described as x. Red can be x plus 25. And navy blue can be 3x. So now that we know these 3, okay, we can sit here and do the guess. So I'm going to draw a little table. This is going to be beige, red. Nope, I need a little bit more. Here, let me teach you guys how to draw this table. If there are 3 different characters, I need 1, 2, 3. It's going to be beige, red, navy, blue. We need to have a do section and a decide. No, decide section. And the last one's going to be declare down here. Okay? I'm going to move all this up just a little bit. Just a little bit. Okay? So beige. Let's guess. Let's take a guess. So let's do trial number 1. Let's say beige. There's going to be a total . Alright, so let's go ahead and look at this. Beige is x, red is x plus 25. Oh my gosh, this is ugly. Let's do a different color. X plus 25, and 3x. And so what are we going to do with all these, right? We're going to add them. I'm going to add them. And when we add them, Susan buys 435 tiles altogether. So it has to equal 435 tiles altogether. So if we take these 3 and we add them, it should equal 425. So let's go ahead and take a guess, right? If it has to equal around 400, I mean, we could guess any number here. Let's try guessing 10, like we did for the last one, why not? So if beige is 10, red has to be 10 plus 25, right? And that's going to be 35. And navy is going to be 3 times 10, which is 30. Alright, let's take these together and let's add them. 10 plus 35 plus 30 What does that equal? 75. Does 75 get us to 435? Nope. Too low. Let's do another guess really quick. Let's go ahead and let me just see how long this video is right now. Okay, it's getting long. Let's guess 100. Or let's guess 50. 50 plus 25. Let me use a different color. Just so you guys don't get confused. 50 plus 25 is 75. And 3 times 50 is 150. Alright. So let's add these three together. 50 plus 75 plus 150. That's 275. We need 435, so that is too low. Alright, so like I said, I could sit here and guess all day. I'm not really excited to do that. So instead of doing that, I'm going to give it the variables. So let's actually do this right. Let's take x plus 25, and 3x, and let's add them together. Let's take x plus 25 plus 3x. That should equal 435, right? Because if we take them together, whatever x is, this is going to be 25 more, and this is going to be 3 times. Let's go ahead and solve. This is what I want you to be able to do. Let's go ahead and solve. Let's combine like terms. 1, 2, plus 3 is 5x. No, I'll actually highlight that. Plus 25. Wrong blue. $435. Subtract 25 from both sides. 5x equals 410. Divide both sides by 5. X equals 410 divided by 5. 82. Nope. Nope. Oh, this is the joy of my life right here. There you go. X equals 82. So that means that right here, this is 82. 82 plus 25. That's 107. And 3 times 82, that is 246. And if I add those three together, 82 plus 107 plus 246, I get 435. And that's what I want. I want it to equal 435. So that's perfect. So our last part, declare. We're going to declare there are, and the declare is just a complete sentence, or not there are. She bought, what did X represent? Beige. 82 beige, 107 red, and 246 navy blue tiles. Let's move this over. Voila. Okay. Alright, let's go ahead and move on to the next page. So the key here is to find out what character is not described, and then introduce it, give it a variable. Describe the other portions, use the relationship, and solve. So the number of students attending the fall play was 150 more than the number of adults attending. So here, the number of students, right, attending the fall play was, so the number of students is being described here. It's going to be 150 more than the number of adults. Student ticket costs $3, adult tickets cost $5. A total of $4,730 was collected. How many students attended the play? So here we have characters, or this part of the story where we don't have portions described. So the number of students attending the play was, we have the number of students attending, but we don't know the number of adults. So we'll start here. Well, what is the describe and draw? What is this about, right? This is about students and adults going to a play. All right, they're selling tickets. They're selling tickets. All right, so the number of students attending the fall play, number of students was 150 more than the number of adults. So we do not know the number of adults, but we know that students, okay, is adults plus 150. So if we don't know what adults are, we're going to go ahead and give it a value, A. Then we're going to add 150. Okay, so that's the students, and the adults, we just have adults. We're going to introduce it. There, if we don't, it's never introduced. So there you go. Another way to say students is adults plus 50, 150. Wow. And the number of adults is A. So let's go ahead and draw a table. Let's draw a long line. We need 2 lines for adults and students. The do you can leave as big. Decide. The last portion is declare. At the bottom. Okay. So let's go ahead and define this. Define a adult is A, students is A plus 150. Alright. What are we going to do with these two? Well, we're going to add them together, right? But something we do need to notice, we're not just talking about tickets, we're talking about money. So, right here, student tickets cost $3 and adult ticket costs $5. The total amount is $4,730. So we want this to equal $4,730. But if we're talking about adult tickets and student tickets, each adult ticket, okay, is $5. So that means that actually I'm going to write this over here. Adults is $5. How much is a student ticket? Student tickets cost $3. Adult tickets cost $5. So adults is $5. Student is $3. So if each adult ticket is $5, that means that $5, I don't need to put dot. $5 for each adult plus $3 for each student. Notice that this is number of adults and number of students. So if it's $5 for each adult and $3 for each student, that should equal 4,730. Okay. So let's say that this is 5 times A is 5A plus, distribute 3A plus 450. That needs to equal 4,730. Combine like terms. $8A plus 450 equals 730 minus 450. 8A equals 4,730 minus 450. 4,280 divided by 8, divided by 8. Divided by 8. Adults was 535. So this is 535 adults. This would be 535 plus 150. That'd be 685 students. If I add these two together, oh no, the question here is how many students attended the play? 685. So let's declare the answer to this question. 685 students attended the play. Alright. Alright. That one is a little bit trickier because there's money involved with the number of tickets sold per student or adult. So that one you have to be mindful of that. Okay. The next problem. A local football game. Children, so this one has money involved as well. Children are charged $2. Adults are charged $5. And seniors are charged $4 for admission ticket. Sorry about that. Last week, they collected a total of $935. There were 3 times as many adults as seniors. Okay. 3 times as many adults as seniors. There are 80 more children than adults. So 3 times as many adults as seniors. So the seniors is going to be 3 times as many adults. There are 80 more children than adults. Okay, so it's right here. It's about a football game. Right here, this is about a football game. So describe, it's about a football game. Tickets. It's about ticket sales at a football game. Alright. Now, who goes to these football games? We have 3 different types of people. Children, adults, and seniors. So, let's read this last section to find out who's being described and who's not. There are 3 times as many adults as seniors. So, seniors, okay, there's going to be 3 times as many adults as seniors. 3 times as many adults. That means that adults is going to have 3 times as seniors. This one's a tricky one. There are 3 times as many adults as seniors. So here, the seniors are being referred to, okay, and the adults are being described. So there are 3 times as many as seniors. So what we need to do is recognize that adults is being described here, and then the next part is there are 80 more children than adults. So children's are being described. Who's not being described here? Seniors. So we're going to go ahead and give them a variable, X. So let's go back and look. Adults. How is the adults described? 3 times as many adults as seniors. So that means that whatever seniors was, it's going to be 3 times that amount. So there's 1, 2, 3. Children. There are 80 more children than there were adults. Well, if adults was 3x, children's is whatever adults was, but they're going to add 80 more. So what expression can I give each one? This is 3x plus 80, 3x, and x. Here we go. Now that we described them, let's go ahead and draw a little table. Seniors, adults, children. X, 3x, 3x plus 80. What are we going to do with them? We're going to add them together. But we need to know that seniors or children, $2. Adults, $5, and seniors are $4. So each adult, each child is $2. So 2 times whatever. This is number of children. So 3 times 3x plus 2 times 3x plus 80. Plus adults is $5, so 5 times the number of adults plus 4 times the number of seniors. If I add these together, they should equal, oh, I forgot to add this side. That should be a total of 935. So let's go ahead and solve this now. Two times 3x is 6x. 2 times 80 is plus 160. Plus 5 times 3x is 15x. And 4 times x is 4x. Combine like terms. $25x plus 160 equals 935. Subtract 160. 25x equals 935 minus 160 equals 775. Divide both sides by 25. x equals 31. X is 31. This is 3 times 31. 3 times 31 plus 80. 3 times 31 is 93. This is 93 plus 80, which is 173. So how many seniors were there? There were 31 seniors, 93 adults, and 173 children. That should declare. Alright, so this is new for you guys. This won't be the only time you guys see this, but here are our notes.